uniform distribution, and then a little bit of some cool stuff review. So the first one is our shoe sizes that are uniformly distributed between sizes 6 to 12. So the first thing you, of course, want to make sure of is that it's between 6 and 12, it doesn't actually start at 0, so you want to make sure that your graph doesn't actually touch the y-axis. So we have 6, 8, 10, 12. And of course, being that it's uniform, it's going to be beautiful and rectangular. And then, of course, we need to determine the height of our rectangle. Complete our graph. So how tall is our rectangle? 1.6. 1.6 because it is 6 spaces wide. Other questions? You can just go on your cell phone if you want. Are you good with the graph? Alright, so we go on to 2. What is the probability? We're going to select Claire has a shoe size larger than 9. So larger than 9, put 9 is right here. A little larger, so that'll be shaded to the right. Larger than 9. How wide is our rectangle? 3 wide. And of course our height is 1/6. We end up with 1/2, 50% chance that our player has a shoe size larger than 9. Questions? So the rectangle is 1, 2, 3 wide. Alternatively, you can think about it as being 12 minus 9 and 9. Any other questions? So then, number 3 was probability that everyone is going to Claire has a shoe size between 7 and 10. So we're between 7 and 10. So 7 and 10. How wide is our blue rectangle? So it turns out it is the same probability. We're talking about the same, amount of shoe sizes. Right. 7 and 10. So my x is between 7 and 10. 7 is the smallest, so it's on the left-hand side, and the biggest is on the greater one. Right. So the x is on the greater one side of the 7, but on the left-hand side of the 7. Other questions? Alright, so then we go down here to the bottom. We have a little blacks from the past. This was z-score. How does one calculate a z-score? There's a formula. What does the formula tell us to do? Okay, there is a subtract mean, there is a standard deviation. We don't subtract the mean from the standard deviation, though. What do we subtract the mean from? Okay, variable, the number in question. So we have a formula that looks like that. X, of course, representing the number in the question that they're asking about. And then we have our mean and our standard deviation. So we just go through, do a little calculating, figuring out each of these z-scores. Now, why are we bringing up this blast from the past? Well, we're going to use this today quite functionally. So we're going to just review the process of finding z-scores. So, number 4, they gave us x of 32. That means we take 32 minus our mean of 25, standard deviation of 5. Of course, 32 minus 25 is 10. We end up with 7/5, but these scores are much more functional when they are decimals. You decimal them around to 2 decimal places, so that should be about 1.40. Questions? So this time we had a constant z-score. If we look at number 5, notice their number is 18. So we're taking 18 minus 25. Well, that's going to end up with a negative value. That's fine. We're allowed to have negative z-scores as well. So 18 minus 25 would be a negative 7 over 5. So that means we have a negative 1.40 for our z-score. And that's all right. We can have that. Let's see. Because those two numbers, 10 actually are the same amount away from me. On number 6, we have a 29.5, so we take 29.5 minus 25 and divide it by the 5. We should get 0.9. And then finally, number 7, our x is 25. So we have 25 minus 25, so that's 0. So our z-score there is 0, which makes sense because if 25 is the number we're looking for, 25 is the mean, so it's going to have a z-score of 0 there at the center of our normal curve. Because it's not far away from me at all. Because it is. Yeah. That's it. Questions? Anything we need assistance with? Things you got to work with? Let's discuss our homework then, which was on page 377, where we have 6 through 12 equations A and C. Yes? I didn't talk down this. Alright, so the first question's 8, we're dealing, no, 6. We're dealing with areas to the left, and so we have color to the left, which is convenient because that means we're just coloring what we're using, what numbers are available on our table. So the first one was z to the left of negative 3.49, which of course is not a whole lot going on out there. So I just scribbled a little bit out there to say, hey, it's out here somewhere. Which of course is not a very big probability, so we get 0.02. However, in C, we want to the left of 0.92, so I'll just go there, 1. And so that's a lot of coloring. And that's a lot of probability, 0.82. Any questions about 6? Alright, so we jumped over to 8 then, which was doing greater than problems, so slightly more complicated because in order to determine greater than values, we need to use the complement. So in 8a, they wanted it to the right of negative 3.49, so again, kind of scribbled out here to the left, and color the rest for you, which of course is a very large probability. When I look up negative 3.49, I get 0.002, and then we have to complement that, so we end up with a area probability of 0.9998. In C, to the right of 2.23 is a very small little space. And so, of course, complement that answer, 0.0129. That is true. There's not ever really going to be a time where officially you calculate 100%, but there are definitely times where the amount that's not being used is so small that you round to 100%. So. Any other questions on 8? 10 were the problems where we had the between probabilities. So it turned out, I realized last class, that I went through the process of, setting it all up, and I didn't write the actual answer down, so I move on. So in the first one, we are between negative 2.55 and 2.55. So of course, you need to take the value that you look up for 2.55 and subtract off the value you get for negative 2.55. And that should give you the 0.9892. Similarly, down here in 10, we look up the value for 1.98 and subtract from that the very tiny value for negative 3.03. So we get the 0.9749. Questions on either of those? All right, and then last but not least, we have the number 12, which are the little tail pieces out on the ends. So the first one we had to the left of negative 2.94 and then to the right of 2.94. So those are symmetric values. There's a little bit of probability out there. So 0.0016 for both sides. So a total of 0.0032. 12C was a little weirder though because it wasn't a symmetric situation. And so when you get to the left of negative 0.88, this larger chunk over here, I got 0.1894. And then when I did to the right of 1.23, I found 0.1093. Added those up, get almost 30%. Any questions on either of those? So all of these that we did last class, we did for our homework, were situations where we were using the standard normal curve at a mean of 0 and a standard deviation of 1. But we've seen many examples prior to this where we had many different means and many different standard deviations to set up those curves. And honestly, you can have any possible number as your mean and any possible number as your standard deviation. And so obviously, as you're working in the real world, it's not the case that you're always going to have a mean of 0 and a standard deviation of 1. So we have to be able to function in the real world, but still being able to get back to the normal curve, the standard normal curve, so we can use our table. And so that's what we're going to talk about today. We're finding probabilities for the standard or the normal curve when we have a different mean or a different standard deviation. Process isn't too different from what we've just been doing. A little added step, a little extra business to consider. So if you will find a piece of paper so that we can write down the steps that we need, and then we will get to some example problems.